Yes, sir.
So observe very carefully. So circular motion is also considered as a two-dimensional motion. So here also always we'll consider two axes. One is y-axis and another one is x-axis. So of course, so it is also two-dimensional motion. Now, as we know that if a body is traveled straight line, basically, for example, from point A to point B. So we all know that the shortest path between the A and B are any 2 points. We used to call something. What used to call everyone? We used to call it as displacement. Clear? So the shortest path between any 2 points, which is known as displacement. Now, same way, if I consider the circular path, see, this is a very important and as well as very interesting concept also. So let me consider this is my circular path now. So having a center. So of course, every circular path is having a center. And as we all know, the properties of circle. What is the property of circle? So if you go from the center O, let me consider O. From that any direction if I goes, so what is that always? Radius is always remains constant. Am I correct, everybody? Yes or no? Yes?
Sir.
Yeah. So let me consider some point on this particular path. That point, let me consider P. So if I traveled from here to here, for example, I reached from here to here, this is what the displacement I have shown. So if it is a straight line, we used to call it simply is as a displacement. But if it comes to the circular track or circular path, the displacement shown by the body, understanding everybody? Clear, brothers? So the displacement shown by the body, actually, if you see from the center, it is making with some angle. It is traveling with some angle. So that is why it is called as, you can notice it, instead of simple displacement, we used to call it as angular displacement. What is to call? Everybody? Angular displacement. Okay?
Angular displacement.
So angular displacement we used to represent with the theta. What is the symbol of angular displacement? Theta. Clear?
Yeah.
So now, this theta is having a two kinds of units. One is the general unit we all people knows. What is the general unit of theta? Everybody? Degrees. Clear? This one. And the SI unit of theta, which is we used to call as what? Everybody?
Radian.
We used to call as radian. Okay. So always you have to remember this. Now, so we all knows that circle means which is equals how many degrees, everybody? One circle means how many degrees?
360.
360 degrees.
360
You have taken degrees. You must know the degrees and radians conversion. Again, you go back to the chapter 1. Those who already studied the chapter 1. There are examples, plenty of examples in NCERT converting from degrees to radians and radians to degrees. Have you checked it, everybody? Yes, please.
Sir.
Yeah, you might be verified already. Okay, so you have to verify and you check it. If you are not remembering, you can again check it out. So 360 degrees means in radians. Can you tell me how many radians it is? Which is equals to
2 pi radian.
2 pi radian. Same way, if it is 180 degrees means how many radians it is? Which is equals to 5 radians. If it is 90 degrees means how many radians? Everybody? 5 by 2. If it is 45 degrees, how many radians? It is 5 by 4.
5 by 4.
So if it is the 60 degrees, then which is equals how many radians? 5 by 3.
5 by
If it is 30 degrees, which is equals how many radians?
5 by 6.
So that is what you have to remember. Now, so let us go back to the class 9th. You remember that circular motion basically speed of a body remains constant. Speed might be constant, but velocity of a body will never be constant. Why, everybody? In a circular path, always at every point, as we all knows that, keep on, what is changing? Of course, the magnitude is maybe constant, but something is keep on changing. What is that? Direction. So that is why circular motion continuously the direction of a body is changing. That is why we can say it is accelerated motion or it is non-accelerated motion. It is said to be, yes, please. Accelerated motion. Because continuously the direction of the particle will be keep on changing. Yes or no, everyone? Please respond. So in a circular motion, the speed of a body might be constant, but velocity of a body will never be constant, as it direction of a particle is keep on changes. Yes or no, guys? Yes,
Yes,
please.
sir.
Yeah. So every point. Now, you might be studied class 9th gravitation chapter also, and as well as first chapter circular motion also. So we all knows that even gravitation chapter particularly they will say. So at every point, if I take now, if suppose if I release if I stop applying the force at this point, the body will go at this point. What it will go? It will goes in a straight line. If I stop applying the force at this point, then from this point, body will goes in this straight line. If I stop applying the force in this case, then the body at this point, it will goes in this straight line. If I stop applying the force in this case, like a boy is rotating a thread, rotating a stone with the help of thread. Do you remember that activity? Class 9th gravitation first chapter. Yeah. So always the angle between the velocity and as well as the applied force, everywhere if you check it, what is the angle it will be? Which will be 90 degrees. Do you remember this one from 9th class? Yes. So always it is. So wherever I stop applying the force, the body will be stop moving. At that point, the body will start moving in a straight line. So this is also how to remember that. So as we know, it is always accelerated motion. So the theta, if you have taken, it is the scalar quantity, vector quantity. It is accelerating motion and is a velocity. So it is a scalar quantity, vector quantity. Scalar vector quantity. Understand? Vector quantity. So it's not a simple vector quantity. We can call it as it is making like an axle. It is rotating a particular point. The body is in a motion with the help of like something like atom. We all know in chemistry atom. So electrons are revolving in the orbit and center who will be there? Everybody. Nucleus. Yes or no? Same way if you take the wheel, the middle it is having the axle and surrounding the wheel will rotate around the axle. Am I right or wrong? Everybody? Yes, please.
Yes, sir.
The same way, a boy is, we all know class 9th, you can see the boy will tie a stone to the rope and he will keep on rotating so that the ball is rotating or the earth is rotating around the sun. So sun is the center who is present and always exerting the force to make the body to revolve in a particular point. So that center only we used to called as axle, like bike or car or whatever it is. So that is why it is called as axial vector. What is to call everybody? We used to call as axial vector. Clear? Understand? Yes, please.
Yes, sir.
Let us take this angular displacement. Sir, how sir this angular displacement is acting? So when let me consider two circles now. So observe very carefully. I'll consider the two circles. So angular displacement, last class we applied one rule to find the direction, clockwise and right hand thumb rule. Do you remember everybody? Right hand thumb rule? Yes, please. Yeah.
Yes,
so now
sir.
let me consider now body is moving in anti-clockwise direction. So I'm taking, so this is what my particle. So let me take this is a P and the body is travel like this direction. Now tell me angular velocity or angular displacement is acting what direction? So this is what the point it has been reached. So this is what the theta. So angular displacement is acting outwards or inwards. Apply right hand thumb rule and you can tell me. So by applying the right hand thumb rule, you can find it. Angular displacement acting outwards or inwards. Apply. Use screen, you can apply. So go your hand, all four fingers from here to there. Yeah, tell me. So your thumb is indicating what? I will apply the four fingers like this. So what my thumb will coming out from your computer screen or inwards to your computer screen? Everybody. Outwards. Okay, others also apply. So that is what? If you apply to my screen also, you people can see. So outwards. What is this outwards? Everybody? Angular displacement.
Anti-clockwise.
So angular displacement direction is outwards or inwards? All of you.
Outward.
It is
Outwards.
When it is a clockwise or anti-clockwise? It is
Anti-clockwise. Anti-clockwise.
anti-clockwise. Remember that. Clear, everybody? Yes?
Yes,
Yes,
sir.
sir.
So for example, let me consider the point here is the point P. Now the displacement, angular displacement shown by the body is this one. So from the center, let me consider now. So now in this case you apply and you tell me. So what is the angular displacement direction? Everybody. Outwards or inwards?
Inward.
Yes, please. You apply the things.
Inward.
Yeah, you four fingers you apply to your thumb will show into the screen or out of the screen. Everybody. Yes, please.
Into the screen.
Into the
Sorry. So it is inwards, and this is called as clockwise or anti-clockwise. It is actually
clockwise.
so in this case, angular displacement direction. What is angular displacement direction? Everybody. It is
Inward.
displacement inwards. Purima, understand everybody? Clear?
Yes, sir.
Clockwise and anti-clockwise. So now if you notice it, can anybody tell me, check your chapter 1 and tell me what is the dimensions of angular displacement? Of course, it has a unit. What is the SI unit of angular displacement? Everybody, just now I told you. What is the SI unit of angular
Radian.
displacement? All of you. Yes, please. Radians. Correct or not?
Radian.
Yeah. So can you verify your notebooks and tell me what is the dimensions of angular displacement? We have written already. It is a very rare quantity which has a unit but does not have.
M0, L0, T0.
Yes. So does not have what, Pradosh? Does not have.
Dimensionless quantity.
Understand, Aswita? Remember anything related to this chapter 1 we studied. Okay. So this is a very, very rare quantity which has a unit but does not have what? Everybody. No
dimension.
dimension. No dimensions. Everybody clear? Understood or not? Please respond, guys.
Yes, sir.
Yes. So that is what you have to remember it. Okay. Clear till here? Any doubt? Anyone? All of you clear? Yes. That is all. Nobody
Yes,
respond. Okay. So now let us see that. We'll find what is this angular displacement. Theta value we'll find it. So what is that formula and all? So let me consider a circle. So we all people knows that. So I'm considering a big circle. So having a center. So choose a center. Everybody follow me when I'm drawing. Okay. So this is the center of the circle. So I will take arc of the length. Let me consider the arc of length. First I will draw. I'll choose. So we all knows that from the center, everywhere it will be. What is that? Equal radius. Am I right or wrong? Others, everyone? Yes or no? Radius
Yes,
is
sir.
equal
Yes,
from the
sir.
center to the any point. So this is the arc I have taken. That is what linear displacement shown by the body. Now we have to find what is the theta. Okay. So let us see that. So this is the point O and this is the linear displacement. Sorry, radius R. And what is the linear displacement? Will represent with what? Everybody will represent with the yes theta. Sure, no. So theta. So let us take the point is at P. Now the point is started moving from point P to it will cover a distance of arc. So this is the arc. Is it okay, everybody? Yes, please.
Yes,
This is the
sir.
arc of a circle. Am I right or wrong, Pradosh? That is what. So now
Sir.
when we take the arc is yes, that is what the displacement consider. That is what we can say yes means. All of you remember length of arc, or we can say what? Arc length. Okay. Now we have to find what is the linear displacement. So we start now, everybody. So linear displacement.
Yes.
Keep in mind, all of you, the formula linear displacement means you can remember always circular. Whenever you get a circular path, immediately your mind should say two things. One is angular displacement and another one is what? Everybody? Linear displacement. Okay. One is angular displacement. Another one is what, Amma?
Linear
Everybody?
displacement.
Linear displacement. So angular displacement, suppose if it make one complete circle, what is angular displacement? Everybody, just now we studied one complete rotation 360 degrees means how many radians?
2 pi radian.
2
2
pi
pi
radians.
radian.
Now go back to the class 9th and tell me one complete rotation. What is a linear displacement? Linear displacement means distance or displacement traveled by a body, which is equals to what? Circumference of a circle. Remember,
Circumference,
everybody?
2 pi r.
Circumference of a circle. How much, Pradosh? Which is equals to
2 pi r.
yeah, 2 pi r. Let me take capital R. Okay, brothers. Radius equals to capital R. Okay,
Yes,
Sai,
sir.
Murali, Rishi, everybody clear? So if angular displacement is 2 pi means what is the linear displacement? Everybody, linear displacement is what? 2 pi
2
r.
pi
2
r.
pi r.
Yeah.
Circumference.
Now, so angular displacement is 2 pi radians means linear displacement is 2 pi r. Then let me consider angular displacement is 1. Then what is the means for 1? Then what is the linear displacement? So what will happen, everybody? So 1 I will keep it. If this 2 pi will come this side, so what will happen? All of you, 2 pi r by 2 pi. So pi will get cancelled, 2 will get cancelled. So if the angular displacement is 1, Means what is the linear displacement? Everybody. Others. Linear displacement is what, guys? 1 means 1 radian. Understand, Ara? Rudreswa?
Yes, sir.
So this is, if angular displacement is 1 radian means, what is the linear displacement? Everybody.
R.
R radians. Now, same way, if angular displacement is theta radians means in the sense of, then what about the linear displacement? Everybody. What is the linear displacement? R theta. Am I right or wrong?
R
theta.
Clear? Understood, everybody? Do you able to understand or not? Please respond. All of you. Clear?
sir.
So that is what. So from this we can write the formula linear displacement. So that is what we can say, that the theta means the theta only linear displacement. So linear displacement is equals to, what is the formula? R. What is the formula, Ra? We got it. That is what linear displacement. What is the linear displacement, Ra? Rudreswa? Linear displacement is what? We assumed as a what? Arc length, which is equals to how much?
R theta.
R theta.
Yes. So S is equals to how much we got? If the theta is making. So S is equals to how much we
R
got?
theta.
R theta. That's all. So from that, very important formula. So arc length is equals to radius into theta. That's all. From the theta is equals to what? Theta means what? Linear displacement. So theta is equals to what, everybody? Theta is equals to what?
S by
R. So what do you mean by S, guys? What do you mean by S? Arc. Understanding? Divided by R means what?
Radius.
R means what? Radius.
radius.
So that is what. So how many of you understand this? Everybody clear? So first formula, S is equals to, arc is equals to radius into theta, and theta is equals to length of arc divided by radius. Okay, guys? Ellam Purima?
Yes, sir.
Yeah, solve here, till here. Anybody having any doubt, kindly let me know it. Completed, guys? Others?
Sir.
Everyone should solve.
Yes, sir.
It will be very interesting when you involve. If not interesting, if you are not showing interest, you cannot. Clear, guys? Now onwards, what you studied previous chapters only we have to find. Okay? So let's start with this. Till here, Aswita, Mani and Samya.
Yes, sir.
Yeah. So complete quick. Any doubt anybody can ask. Ishali completed? Murali? Monish?
Yes, sir.
Yes, sir.
So now, let us take now velocity. Can you tell me from the second chapter? Can you tell me what is the velocity formula? Velocity is equals to 11th class. You tell me. Don't say like kids 9th class. According to 11th class, finish this concept. So we learned it. Now, can you tell me what is the velocity formula? From the class 11th, velocity is equals to differentiation. Ra, we studied velocity is equals to what? ds by
dt.
dt. Yes,
dt.
or no? Yeah, change in
Yes, sir.
displacement divided by change in time period. Am I right or wrong? Everybody,
Sir.
same way. Now instead of velocity, we have to study angular velocity. What is that, everybody? We have to study what? Angular velocity. So angular velocity will represent with a symbol W. So this W only we used to call as omega. What we used to call? Omega. So omega is equals to. So what is the displacement in a circular motion? Displacement, angular displacement is what? Angular displacement is what, guys? Theta. So angular displacement is theta. So here what will come? You should speak, I should not. Delta theta divided by time period. Change in time period. Delta. Is it okay, guys? Yes, please.
Yes.
Yeah, what do you mean by this? Can you define? Here, see, change in displacement for unit time. That is what velocity we used to call it as. Same way, what is angular velocity? Anybody? Change in theta means what is that? How much? The how much angle per how many seconds? How much angle is changing per how many seconds? Per unit time or 1 second you can consider. So that is what we called as angular velocity. Is it okay, everybody? So what is the formula for angular velocity? W is equals to, everyone, delta theta divided by
Delta T.
delta theta divided by delta t. So now, so let us find the dimensions of, okay, let me write the dimensions of, SI unit of angular velocity. So what is the theta unit, everybody? What is the unit of theta?
Radian.
Unit of theta are radians.
Radian.
Time is what? Seconds. So this is only we used to call as, what we used to call? Radian per second. Is the SI unit of what? Everybody? SI unit
Omega.
angular velocity. Next, dimensions. Brothers, tell me dimensions. Dimensions is equals to, we all know that radius does not have any dimension. So what will happen? Dimensions of angular displacement divided by time. So we all know that angular displacement, what is the dimension?
Power 0.
M0
T power minus 1.
0.
Power 0
What is the time displacement? T. So that what is the answer? Dimension.
T power minus 1.
M0 T
T
power
power minus 1.
minus 1.
Okay. So angular velocity, what are the dimensions of angular velocity, everybody? M0, L0, T power. T power, everybody. T power minus 1. Am I clear?
Minus 1.
Understand?
Yes, sir.
No. So that is what you have to remember. So this is only we used to call as, what we used to call angular velocity. Okay. So now
Velocity.
we all knows that V average formula. Same way you tell me. V average, we all knows that. What is the V average formula? Again, same thing. Sum of the individual displacements divided by total time period. Am I right or wrong? Everybody?
Yes.
Same way. Angular velocity average also same thing will come. Delta T theta divided by delta T. Is it okay, Rudreshwar? Pradosh? Yes?
Yes, sir.
Formula. Now,
Sir.
consider a small period of time. So we all people know that we modified it. Small interval of time, then something will come. If you want to break it, we have to use differentiation and integration. Small interval.
Differentiation.
Small interval of time. Yes, please, guys. Means in the sense of
Instantaneous.
almost delta T is equals to what? Almost delta T is equals to what? 0. Then that is only we used to call something. Anybody can tell me? Very
V
particular. Yes. What is that, Rudreshwar?
V instant.
V instant. Very super. That is what. If you studied, you can. So V instant. In our instantaneous, what we used to call? We used to call
Instantaneous velocity.
Yes.
velocity.
Remember, Pradosh, Laksha? Instantaneous
Yes,
velocity.
sir.
Aswita? Instantaneous velocity. So by the time we have to apply differentiation and integration now. Differentiation is equals to ds by d theta. Same way. Here also consider very small interval of time, almost time is equals to 0. Then angular velocity, instantaneous angular velocity is equals to, what is the formula? Everybody? D theta by dt. Any problem for anybody? You can ask. Clear? Understood? All of you?
Yes, sir.
That's all. Finish it fast. Till you complete it. Take time, no issues. Unless you understand, you cannot. Mane and Samya, understood or not?
Yes.
Please do it seriously. Ellame puriyuma. Nobody is saying anything.
Yes, sir.
So finish it quick. Yeah, next. Write the question, first question. Theta is equals to 2t square. Q is question number. Theta is equals to, theta means what? Linear angular displacement. Theta 2t square plus 2. Okay, find omega in 2 seconds, and at 2 seconds. So you might be understand in 2 seconds and at 2 seconds. Enna difference irukka theriyuma ellame? Yes, please. All of you.
Yes.
So in 2 seconds means in 2 seconds means totally what is the total time? Everybody? What is the total time? In 2 seconds means what is the total time? That
2
is what
seconds.
question. All of you?
2 seconds.
2 seconds.
2 seconds.
First thing. So we have to find. So in 2 seconds, they are asking certain time period 0, 1, 2 like that. So that we have to find what? We have to find angular velocity in 2 seconds. So means in the sense of from 0 to 2 seconds. So we don't know. 0 seconds, 1 second, 2 seconds. So that we can calculate what? We don't know something. So totally we are going to calculate. So we will use what? Yes, please. Average. Understanding, Ra? That is what? So delta theta divided by delta t. So which is equals to delta t means what? Delta t at 0 and theta at 2. Am I right or wrong? Everybody?
Yes, sir.
Yes. So means in the sense of, can I write it as a t2 minus t1 divided by, so what is the time given? 0 to 2. So 2
Yes, sir.
minus 0.
2 minus
2. Yes. So substitute theta 2. Theta 2 is equals to 2 seconds, 2 seconds, and theta 0 is equals to 0 seconds. So substitute in this equation and tell me what is the theta. Theta 2 is equals to 2 into 2 square 4. 4 to the 8 plus 2. How much it is? 10. Am I right?
10.
10.
10. Next minus. Here again substitute 0. So 0 will go means how much will come? 2 into 0,
2.
0 plus 2, which is equals to 2 divided by 2, which is equals to 8 by 2, which is equals to how much?
4. 4 meter.
Average. What is the units? Not meter per second. What is the units? Radian per.
Radian per second.
Per second.
That is what. So please write it. So what is the answer? 4 radian per
Second.
4 radian per second.
Seconds.
Yeah, that is what. Next, at 2 seconds, time is specified at 2 seconds. So that we have to take it what? At 2 seconds, we have to consider something, particular small, that particular time period they are asking. So we have to kind what?
Between 1 and
At instantaneous. So angular velocity at instantaneous. What is the formula? D theta divided by.
d theta. dt.
So substitute the theta value 2t square plus 2 divided by t. Yeah, fastly tell me. Apply the differentiation and tell me fastly.
4
Differentiation of t square 2t square. What is that? Pradosh? 4t. Understanding? So 2 constant. T square. What is the differentiation? Differentiation of 2t. T square is 2t plus differentiation of 2 is what? 0.
0.
40, which is equal to how much? All of you? 40. Now time is
40.
equal to up to 2 seconds. Up to 2 seconds means 2 is equals to 2. So that what is the instantaneous velocity? 4 into 2, which is equals to how much? 8 radians per second. Okay. So angular velocity, instantaneous angular velocity is 8 meter per second. And what is the average? Average is 4 radian per second, not meter, radian per second. I hope you all understand. Laksha, Asmita,
Yes, sir.
that is what. Okay. So what is the difference between, see that? Find W in 2 seconds. So in 2 seconds means from 0, 1, 2. So within the time period we have to find. So within the time period means we have to calculate what? Angular velocity, average angular velocity. Next, at 2 seconds means particularly at 2 seconds what it is. That is what you have to remember. So then we have to use differentiation and integration at particularly. Yes, please. Differentiation. Let me understood or not? I want
Yes,
to know.
sir.
Yeah, that is what. Next, we all knows that differentiation of V velocity formula. Tell me V instant or whatever it is. So V is equals to ds by d theta. Now I want to find reverse. I want to find displacement. So what we have to do? Pradosh, we have done integration or differentiation. Yes, please. So I can make it ds is equals to v dt. I want to find So we have to apply what? Both the sides have to apply integration. So integration of v dt. This formula so many times we have written. Integration of ds is what? Integration of ds is
Integration of VD.
integration of
VDT.
ds is into integration of v dt. Am I right or wrong? Everybody.
Yes, sir.
Same way.
Yes, sir.
Yes, sir.
Angular velocity, which is equals to d theta by dt. So which is equals to d theta is equals to omega dt. Now apply the integration in both the sides. So integration of d theta is what? Differentiation of d theta is everyone.
Theta.
Theta. So theta is equals to what? All of you.
Integration of
Integral angular velocity d theta. Okay, omega dt.
Yes, sir.
dt. Let me understood or not?
Yes, sir.
Yes, sir.
Yeah, very important, Amma. Please remember that. Now, let us calculate one interesting thing now. So we have to find this angular velocity. Shall we start finding the angular velocity, everybody? If you are all okay, then we'll find. Now, so we all knows that if you take the circular motion at every point, velocity is acting perpendicularly to the radius. Am I right or wrong, everyone?
Sir.
Yes, please. So any point if I drop the, for example, if I drop the here body, so the velocity is acting what? Generally, normal velocity is acting vertically. It is acting vertically, upward direction. Am I right or wrong?
Upwards.
Yes, please.
Yes, sir.
Yeah. So that is what you have to remember. So here the velocity is used to act. 1 minute. I'll adjust it and I'll make it. Now you can notice it. The velocity is acting here at this point. If I check it, so velocity is always acting what direction? As soon as if I release the body, it will go in a what? Perpendicular. Am I right or wrong? All of you. So let me consider
Yes, sir.
the dot center point, and if I make the arc, so what is that point from the center? We used to call something. What we used to call as?
Radius.
Yes. All of you. We used to call as radius. The radius, and this is the velocity. Then suppose let me consider the body is make. This is the arc is traveled by the body. Then the angular velocity. This is actually the displacement shown by the body. Am I right or wrong? Arc. Yes or no, guys?
Yes.
Yeah. Then
Yes,
the
sir.
angular velocity means what the angular velocity made by the body at this point, which we used to represent with the what? Everybody. Yes, please.
Omega.
So omega is equals to, now I will say you. So if you want to find the speed, so speed is equals to formula. We are going to derive now. So speed is equals to radius into omega. So what is the formula will come? This is the omega. So radius into what will come? All of you. Radius into omega. From that, omega is equals to, can anybody tell me angular velocity formula? Omega is equals to velocity.
Velocity by radius.
Sir, how it, sir? Shall we prove it now, everyone? So we can prove it with the help of this. So observe very carefully. So we are having a two displacement in circular path. What is that? Everyone respond. One is what displacement?
Angular.
Linear displacement.
Linear.
And second one is what?
Linear.
Angular displacement. So what is the formula? Angular linear displacement formula? S is equals to r theta. And what is the angular displacement? This is linear displacement. What is the angular displacement formula? Theta is equals to everybody. Theta is equals to S by R. Am I right or wrong? Everybody?
Yes.
Yes.
Yes, sir.
So let us consider if it is a short interval of time. So let me take the displacement. That is what the length of the arc. Let me consider as a delta S. And the here theta. So if I am considering here delta S means here what I consider? Delta theta or only theta? Everybody? Yes, please. It will become what? Delta theta.
Delta
Sir, no.
Delta
And let
T.
me take the time period is delta t. What is the time period, everyone? What is the time
Delta
period? Delta t. Clear? Respond, everyone. So what is the time period,
Yes, sir.
everybody? Delta t. And we have to find the relation now for omega. So shall we start doing, everybody? All of you?
Yes, sir.
Yeah. So if we take the omega, so as we all knows that velocity formula. What is the velocity formula? In velocity is equals to what? Change in displacement divided by change in time period. Same way, we all know angular velocity formula. What is that response? Change in theta divided by
Delta
change
T by
in,
delta T.
yeah, change in linear displacement divided by change in delta t. Now, so we all knows that from that. Let me write this one delta. So theta means what is the answer? We got it already. Theta means what is that? Read it. Theta means what? S by R divided by delta t. Any problem for anybody? You can ask. Now, as we all knows that R is always remains constant or varies? Ellame solunga. Constant. So that differentiation is applicable or constant, sir? It's not constant. Yes or no? It is not applicable. Am I right?
Yes, sir.
Yes.
Yes,
So
sir.
that I will bring the R outside. So what else is remaining? Everybody, R I am taking outside. So 1 by R. So what is remaining? Delta S divided by
Delta T.
delta t. So we all knows that delta S divided by delta t, which is equals to what?
V.
V. So that,
V.
so we all knows that W is equals to 1 by R into V. So W is equals to V by R. From that, V is equals to what is the formula? W not it is.
W into
We should not call it as
Omega.
W.
omega into R.
Angular velocity. You should call it as what? Everybody? Angular velocity. Understanding? Remember that. Remember this formula only for circle. Both S is equals to R theta and V is equals to omega R. Both are only for applicable to what? Only for circle. Clear?
Circle.
That is what you have to remember. And all of you keep it in mind. This one is not a vector, it is the scalar, because based upon the clockwise or anti-clockwise, always you remember, all of you. So velocity, you can see, if the omega is acting perpendicularly, for example, this direction, you can see. So velocity is always acting like, we can see upwards or downwards, every point, if you consider. So we all people knows that. So always, what is the angle between them? We all people knows at any point you can take from the center. Everybody, just already at the beginning I told you. So this is the radius and here is the velocity will act. So that, what is the angle between them? Everybody.
90 degrees.
90 degrees. So if I consider this point also, here also, what is the angle? Everybody. 90 degrees. Next. So at this point also, what is the angle? Everybody. 90 degrees. Understanding? So at this point also, what is the angle? Everyone.
90 degrees.
90 degrees means in the sense of omega is what? Omega is the perpendicular to V. Am I right or wrong? Everybody? Yes, please.
Yes, sir.
That is what. So I will say that all of you remember, very, very important. So this is not a scalar. You should not write V is equals to R into angular velocity. This is the wrong answer. Wrong. You should not represent the arrow. It is a what? It is not a vector. Okay, so that is what you have to remember. And always, what is the angle between them? Everybody, the angle
90.
between them is 90 degrees. So W is equals to, what is the formula? Respond. V by R, or V always what? Perpendicular to what? Everybody, W. So that omega is equals to V perpendicular divided by R, not V by R. You should write, what you have to write, guys? Not V by R. You should write what?
V perpendicular.
V perpendicular. Clear? Understand?
Yes, sir.
Yes, sir.
So W is equals to V perpendicular divided by R. So till here, everybody complete it. Anyone having any doubt, you can ask. Do it fast, everybody. Brothers, ellame clear?
Yes, sir.
So very, very important this is for circular motion. We are going to solve one question and we'll wind up. Meeting is going to end, join back and we'll continue from here. Make